Question. Draw the free body diagram for the following charges as shown in the figure. The three diagrams are given. Before we discuss these three diagrams, let us learn first about what is free body diagram. A free body diagram is a simple to analyze the motion of the object using Newton's law. There are three steps to be followed. The first one, we have to identify what are the forces acting on the object. Second, we have to represent the object as a point mass. Third, we have to represent the forces vectorically. Here there is a simple example, a man standing on the floor. He is represented as a point mass. The weight is acting downward, that is W, with an arrow mark downward. And the floor gives a normal force in the upward direction, that is given by an upward arrow mark by N. These two arrows must have opposite direction and equal in length. This is simple free body diagram. So let us go for our cases. First case, free body diagram for the first system. Here there are four forces available. One is the electrical force that pulls the charge on rightward. Then there is a spring force that pulls the mass on the leftward. Then there is a gravitational force acting downward, and the floor gives a normal force in the upward direction. So we have to represent the object as a point mass now. Right, good. Now we have to represent all the four forces vectorically. The first force is the electrical force EQ that act along the x-axis, positive x-axis. Then the spring force Kx that acts along negative x-axis, though Kx minus I cap. Then there is a gravitational force that acts on the body vertically downward, so mg minus I minus j cap. Then a normal force acting upward, that is n j cap. This is a simple free body diagram for a given system. Let us go for a second case. Here, what are the various forces available? One is the gravitational force acts downward. Then there is an electrical force that pulls the charge towards the rightward. Then there is a tension along the string towards the point of suspension. So these three forces must be represented vectorically. Let us first represent the object as a point mass. Next, the first force, electrical force EQ that act along positive x-axis. Then second force is a gravitational force that's vertically downward, so mg minus j cap. Then the third one is a tension that's an inclined one. This is resolved into two components. One is vertically upward, that is T j cap. Then horizontal component that's towards left hand side, that is T minus I cap. This is a simple free body diagram for our second system. Let us go for the third system. Let us find what are the forces acting. The simple gravitational force acting downward. Next, there is an electrical force acting upward. Remember that this body moves with uniform velocity towards right. It's injected towards right. So uniform velocity means there is no force acting on it along that direction. Right? Okay. So let us represent the given body as a point mass. There are two forces. Let us represent them vectorically. One is electrical force EQ in the positive y-axis, and the next one, the gravitational force along negative y-axis. It is mg minus j cap.